host, Mike Schwartz, founder of Glue. Today is episode 208. A quick reminder to follow the live stream on LinkedIn or YouTube. The topic today is proof of continuity, and our guest for the third time on the live stream is Nicola Gallo, co-founder and CTO of Nitro Agility. Welcome, Nicola.
Hi, everyone. Nice to be here once again.
So we're going to dive right into the topic, which I've shortened to proof of continuity. And Nicola, you provided some diagrams today, and I'm going to attempt to show them. So let's start with hopefully this first diagram. I think it is. Oh, I should have practiced. Now it's showing me all of my, all right, let me just go for.
I'm going to look for it, 1 second.
I'm just going to do screen one. Here we go. And show it. So this first diagram, you call it the N+1 executor problem. Can you explain this? Just walk us through this diagram. I hope people can see it. I know people are looking on their phones. It might be small.
Yeah. I mean, as I said in my first episode, my background is on distributed systems. So I started to look at this security problem because I was mainly working with Apache Kafka use case, so stream processing. And this diagram is showing, I mean, I don't think they see, there is not anymore the diagram.
Yeah, I switched it back. I'll try and bring it back in a second.
Yeah. So what happens is that when you are working with Apache Kafka, you are working with stream processing. So when you are working with stream processing, you have a producer, which is an executor, which is publishing a message. And after publishing this message, there will be a consumer. So with Apache Kafka and stream processing, when people they were building, there were hype around microservices. Mainly they were talking about choreography and orchestration. Orchestration is when you have a central orchestrator. Choreography is when you have lots of consumers that starting from the same message, they can start doing something, okay? So let's suppose I publish a message. This does not mean that there will be a single consumer. There could be multiple consumers in different point in time to consume the message, okay? So once you understand this, you have this use case. So you have an executor N. So this is the executor which is going to publish the message. So you're not going to make an HTTP call, but you are going to publish a message, which is a very common use case in any enterprise. When you publish this message, you need to delegate the next executor. But here you've got a problem. You don't know which one is the next executor. And probably by the time you are publishing the message, the next executor does not exist because it will be provisioned at some point in time in future. And after it will be provisioned, you will need to read your message and continue, okay? So if you want to build this in a secure way, then you start looking at the real problem because actually you need to delegate something that you don't know. You don't know which one is the identity. You don't know which one is the identifier. So if you have to delegate something that you don't know, you don't have the identity and you don't have the identifier, who are you going to delegate? This is a real use case. It's very common. It's behind every perimeter in any enterprise. So when I start looking at this problem, I started to understand there is something that was not working. And by the time, the first episode, I was saying that actually auth cannot solve this problem. Okay, by the time nobody was questioning auth, Now, many, they are start thinking to patch or off or rewrite or off. So why this is happening? Because the AI agents, they are
Wait,
acting
can I just
exactly that way.
pause there for 1 second? And yeah, so you're saying that OAuth doesn't handle these use cases, and so we need some type of new development to address sort of these new use cases to prove continuity from, let's say, the time something started to a new process that's trying to process a thing downstream. And I think everyone would agree with you there that that proving continuity is important. And delegating or attenuating permissions is important. And I think that sort of leads into, can I show the second diagram or attempt to show the second diagram? So in the second diagram, and let's see, I said I shared it. Man, let's try it again. It's not adding it. Okay.
I've sent it on LinkedIn.
Well, okay, wait, I found it. I found out why. I'm fumbling Restream. I didn't see I needed to add it as a guest. Let's see if we can get it in a better view, actually. Maybe, what about, no, not really. I think we need to show the whole thing. Okay, well, let's go. So we were talking about how continuity is important. And here we have another example of continuity, of moving from one. But here, I think what you're showing is the danger that potentially downstream, what if we combine two differently scoped sort of permissions, and they end up doing something we didn't intend. But we'll walk us through what's the concern here that this diagram is talking about.
Yeah. So continuity. There are two use cases. The one that we saw before. So delegate what you don't know, and then there is another problem which is a lineage problem. Okay. So let's suppose I've got Bob. So here we've got behind this identity Bob, still Bob in both of them. So let's suppose Bob connect to a software as a service and say, look, I want this software as a service allow Bob to back up its own file. So Bob is going to review the service agreement. He's going to say, oh, look, I'm based in Europe. The backup is in Europe. I'm fine with Europe regulation. I accept to back up all my data in this software as a service. So he's going to click the button, create a first token. This token will have a read all and backup scopes. So those this token is going to go through the executor. Okay, and this is easier to see if you are thinking in terms of capabilities. Okay, and this is one single execution. Then there is another feature of the platform, of the same software as a service, that allow the user maybe to pick a document, summarize it with the AI agent, and share the summary to a friend. So in this case, Bob is saying, look, as this service is not provided in Europe, but just, for instance, in USA, I decide to use it just with the document foo, because it's classified in a way that is fine to have it processed in USA. So Bob is going to create this new token. There will be read foo and share files. Okay, those two tokens that they will go through the distributed system. At some point in time, there will be some attenuation. So the first lineage will become read all. The second lineage will become share files. And I've got those two tokens. At this point in time, the executor n wants to delegate executor n plus 1 and decide to compose those two, for instance, capability in one, and send to the executor n plus one, okay? The executor n plus one would receive a valid token and is going to execute it. But here you have a problem because you are going to share all the file. Bob never requested to share all the file, okay? So in capabilities, how do you avoid this? With posture. So you are going, in a capability world, this is a bug. So you're going to say, look, if you are combining those two capabilities, they are a bug, okay? But what is the point? The debug is still creating a security state which is valid. So let's suppose you are using an AI agent and you cannot trust it. It may also have bug.
Yeah.
The agent is going to be able to create invalid state. So how can you deal with this? This is an invalid state. I don't know if it makes sense. So this is something that a protocol should not allow to do. Do you agree?
I do agree. And it shows that attenuation by itself isn't sufficient, because if you have attenuation, but then you have something that collects these attenuated tokens and puts them together in new ways, you actually can get new capabilities.
And in capabilities world, you have also the composition. So in the off world, you don't have. So in the off world, you have token exchange to attenuate, which is fine. Usually, you don't take two tokens and merge them, okay? But in a capability world, you have this use case. So the point is...
Wait, can I just pause there? So
Yeah.
when in OAuth, when we do a token exchange, there is no standard token exchange, right? There's various profiles for token exchange. Transaction tokens itself is a profile of token exchange. And so there's nothing that says you couldn't do a token exchange and get back a PIC token.
I think it can happen.
Yeah. So, but I think the idea you're making here is that in general, as a rule of thumb, we say if you have n number of scopes, you do a token exchange, and we mint a new token with a subset of those scopes that's attenuated, and that's normally considered to be good security. But you're saying that by itself, it actually might not be good security, or it's not enough.
There are use cases because when you need to compose two actions, or if there is a bug, because what is the point? In a security system, you cannot avoid bugs. So let's suppose a system receives a token and the token has the scope read. If the application decides to delete instead of read, that's not an off bug. That's an application bug. The protocol cannot do nothing. I mean, if the token say read and you write, there is nothing to do. So the only thing that a protocol can do is to avoid that an executor can mint a new token which represent a valid security state, which will be executed by another system. That's why you need the security protocol to instruct the next executor via API, messaging, whatever you want. So, as we saw before, if you use composition, you are able to build a valid security state, and you're going to hack the next part of the system. And here we are relying on posture. So we are mitigating the problem. We hope there are no bugs, but bugs are able to create an invalid state. Instead, PIC is saying that if you add in the picture the temporal aspect and you respect the two lineage, it's impossible to have this invalid state. I don't know if it makes sense. That's what in the paper I've been discussing.
Yeah. Actually, I'm glad you mentioned the paper because I actually wanted to pivot to that topic. So actually, I reached out to you when I read the paper because I thought this is really interesting and we should I had some questions about it. So I always say Identity office hours is my office hours with you to get me to, so I can ask my questions about this paper. And I have a couple because especially about the math. But the paper is, of course, linked on the episode notes. And as everyone knows, we have a shortcut, glue.co/IOH- the episode number. So this is episode 208. So check out the paper. I also included a link to YPIC and a post from Nicola, and I'll post the takeaways there. So talking about the paper, it's an interesting paper. It looks like a math paper to me. It's basically a math paper. And so my first question is like, who in the community other than Alan Karp has the ability or the time to actually verify that the math is actually right in your paper? And if there isn't a big enough community, might it be a good idea to actually put that math into Lean and formalize it so you can prove that your math is right, so we don't have to worry about or wait for the math experts to actually bless it?
Yeah, I mean, starting from the last, the Lean test, I mean, I was not aware of it. I'm going to do it and come back to you, okay? In terms of the paper, so once again, I started looking at distributed system. The mathematics which is in the paper is very simple. It's just set mathematics, so it's not complicated. So as it's myself, I use formal math to express better the concept to myself and try to explain it to other people. Because what I found is that every person has a different opinion on terms and becoming confusing. So using mathematical notation, it becomes easier. In terms of validating, for instance, now I'm working also with the Italian research department, the CNR, which is the Italian National Council. And we are also working on a paper with them that hopefully in a few months we are going to submit it to an IEEE conference. So that will be reviewed paper. So we are working on this.
And okay, so now, if I may, I actually would like to ask you some questions about the paper itself and some of the math in the paper, because I was a liberal arts major, so but the math is interesting, and I think this is the direction that we're going. It is getting complicated, and we do need math in order to be able to prove the trust is built on these math algorithms, and we need to know these math algorithms are actually correct and provable. But let's just look at the math for a second. I'm going to try and not fumble the screen sharing as badly this time. I see the error of my ways now. So this is sort of from the middle of the paper, or no, this is from the beginning. My question here might sound like a silly one, but why do you call this pi? Why is this pi? And what is this equation telling us?
So this is exactly the sequence that we were looking at in the first diagram, the n+1, okay? So in math, that's a series, okay? So what we are defining an execution, so this is the symbol that I use to express the execution, okay? So the execution, what is a collection of steps, so S0, S1, up to Sn, and each of these step should be a valid continuation, so should carry with it the right continuity. So that's the authorization context.
Okay.
So you need to represent it as a series. But in math, look at this. S0, S1, let's suppose there is S2, okay? If you look at in terms of execution, that's a single instance of execution. You know that 3 comes after 2. But if it is not S3, if there is not the math, so the number 3, how do you know when you are looking at an AI agent or a workload executor, if it is number 1, 2, or 3? I mean, you don't know. So you have the concept of time. So you have an execution that is executing in time, and you have multiple ops. And the simple example to see this in real-world system is Apache Kafka. When you are building choreography with Apache Kafka, each consumer is one of those steps. I don't know if it makes sense.
And why is it pi?
Because I liked it to represent the execution. It's that simple. You can pick the name. There is not a rule.
Okay. Let me show another one. Now, when you say that math isn't complicated, actually, no, it wasn't this one. Okay, it's the next one that I totally didn't understand. Now, this seemed like it was important.
This is the core concept.
Yes.
So before, when we have been looking at the first diagram, I explained the problem, but I didn't provide a solution because I said, okay, I have executor n, which needs to delegate n plus 1, but we don't know the identity of n plus 1, we don't know the identifier. So what am I going to delegate? Okay, so how I solved this? Pick works in a different way. Instead of delegating the future, pick try to connect the past. Okay, so I'm going to give you an example, a programming language example. Let's suppose I'm writing a piece of code and I have the data access layer. I'm writing the data access layer for SQL Server. Okay, then I decide that my application needs to be able to connect to multiple databases. So what I do when I'm working, building the software, I'm going to create a contract, an interface. I'm going to say, look, I don't know which one will be the real implementation, SQL servers, PostgreSQL, file system, whatever. I'm just going to make sure there is a valid interface. So in PIC, how things work? The executor, in order to continue, has to prove that is the valid continuation of the previous step. So the previous step is going to provide a contract. It's going to say, look, in order to execute this, maybe you need to be an executor which is part of the sales department, and you are located in Europe. So that's a contract. So the next executor, in order to go ahead, has to prove that there is a relationship to the previous step. So using the proof of relationship is going to build a proof, which is a first part of the artifact, which is proving that S1 plus 1 is part of the same execution of SE. Okay, so this is the first part of the bit. Then there is another part. It's not enough to prove that you are a valid continuation. You need to make sure that the continuity didn't expand. So let's suppose, what I mean by continuity. The continuity is composed by operation. So let's suppose I have the scope read and write. Those are operation. Then is composed by characteristics. So any sales department and any European location can execute this. Those are constraints of the execution. So what are you going to do is to make sure that this constraint, operation and execution characteristic never expanded, okay? So at least you can, or they stay the same or you attenuate them. So what is saying this? That in order to get a valid transition, for each SE and CI, there should be always this equation which valid, which means that you are building a chain in memory, okay, that is going to be validated for each step. So in this way, you are building a proof of relationship, building the proof of continuity with the proof of relationship, and you are going to send to the next executor. The next executor is going to go through all these steps from the first to the last and make sure that this continuity worked. That's in math. Then in reality, you say, but are you telling me that you are going to bring with us all the history? No, you can avoid it. You can have just the last token. I don't know if I was able to explain it.
Yeah. I'm gonna show the third. I think that was good enough for me. I'll have to take your word for it. Also, there's a transcript of the episode, by the way, that I'm now posting. Restream now gives you a transcript, and I put that up on the wiki. So if anyone needs to read that back slower, you can do it after. Let's go to diagram 3, and I'll try not to fumble this one either. I thought this is interesting because this is sort of how you started the paper, by talking about basically privileges. And yeah. I'm wondering, is this really necessary? Because this is interesting, but is this really necessary for the paper?
Yeah, because that's so the paper starts from this. Okay, so another point. When I say identities, we don't need identity, I don't mean we don't need identity at all. We need identity to create the authority. So as now we have OIDC to authenticate the user, we still need OIDC, okay? We still need the wallets, we still need verified credentials and so on, okay? So what happens is this. The paper starts saying something which is very specific. Each authority at some point in time is created. So who is going to create this authority? Has to be an identity, but maybe is it going to be a human identity or a not human identity? Is it going
software
to be
identity?
or it's going to be a role?
Software. Yeah.
Or is it going to be a role? Because let's suppose I authenticate with a workload identity, and then I assume a role. At that point in time, the permission entity is the role, it's not the workload identity. So the paper what say that the authority, in order to be created, has to start with a permission entity, which can be human, not human identity, role, whatever, and has to express this identity, this permission entity, as some privilege, okay, as some permissions, sorry. So to this identity, we have permission attached to it. So when we want to create the authority, we need to select a subset of those permissions and say, look, for this specific execution, I want this scope to be valid. So even though I am able to read, write, and delete, I decide that between these three permissions, I want just to pick read and write. That's it. So when I pick those two permission, I've got a privilege. Okay, and this is the basic of the is required for the paper, because the paper is showing that it's not enough to have object, the operation and the resource. You need another element, which is the lineage, the time. Okay, so that's why it's in the paper, because that's the basic element which show why we need the time. For instance, the second example where we were composing the two capabilities, that's the case, because if you don't have in the picture the time, it's fine to compose those two capabilities, but we have an invalid state. But why is it invalid? Because we forgot to add the lineage, the time. I don't know if it makes sense.
Yeah, but I wonder why, you're basically elevating identity-based access control there. And actually, what we don't actually always know the identity. Sometimes we just have some evidence in the context that we're dealing with a certain human or piece of software. So I don't see why that's necessary for part of your paper. And really, I feel like you could take that whole part out and just say, well, you're starting at a certain point where you have a certain level of privilege or access based on the evidence that you currently have at that point, based on the facts that you know. And I feel like you're just elevating identity-based access control for no reason.
Oh, wait, there the privilege start from operation and resources. Then, if they comes from an identity, a role, whatever, the paper doesn't care. It's just saying that there is a root because the authority has to be rooted to something. The
Right.
permission entity which has the privilege to define that authority. Because the authority has to be created by someone, an identity, human, not human, whatever. You
I
cannot
don't
create
know. I think
authority from nothing.
that's just confusing. You're just promoting identity-based access control, and
No,
it's easy to figure out what humans are allowed to do based upon a policy store. It's pretty easy to figure out what the humans are allowed to do and what the software is allowed to do. So all we need to know is we need to build our policies based on what actions are allowed on what resource based on what context. We don't need that principle. And by you orienting the whole paper around principle, you're basically making one big case for like identity-based access control.
so wait. So I can see where you want to go. So when you speak about policies, the authority is here. We are talking about authority propagation. If you authorize point to point, you are always going to be attacked with confused problem and so on, because at the policy layer you don't know, you cannot express this, you don't have the time. So the policies, they are still good. So once you are propagating, okay, those operations, they are labeled. Then of course, once you got those label, you will need your policy decision point, which is going to receive an input, because end of the day this is a token, and is going to go and to be validated by your policy decision point. But keep in mind that the policy decision point has never to expand. So how can you prove that your SEDAR language is not expanding the original authority? You cannot, I
Well,
guess.
so I'm not suggesting one policy syntax or another here.
Whatever, any policy
I'm
language.
just saying that your orientation here is that the authority originates from a principle, either a software or human principle, but you're still saying, okay, authority originates from a principle, and that's what we call identity-based access control. And I think what we've seen is that that's sort of a dead end, and it would be better to just to say, let's manage the capabilities, the action resource pairs, and then in terms of the identities, we're going to make policies about the facts that we have. Some of those facts might be about humans or software entities, but a lot of them are about claims anyway. And so I think that's I think it doesn't even matter to your, like, the reason I started with the continuity, the step one, is because I think it doesn't even matter, but you start the whole paper with this part that's just completely irrelevant to your whole argument.
I mean, that's a label. It could be
To your
the
argument.
same concept will work also if instead of having operation and resource, you would have, I don't know, role. Let's suppose we have in DigiWT
Or
token
why
my
not
role.
just action on resource?
Yeah.
Can this action on this resource happen with this context? That's the question, not who is allowed to do what. Can this person do it or can this entity do it? But is this action allowed on this resource given this context? In the context are a lot of facts. There are tokens. There's data pipelines in the back bringing in trusted data.
But
There's also, potentially API calls and, let's say graph results. So the context has all this information. Based on that information, we have policies, but we don't need the subject or the principle is not. We don't originate all authority from a person and go down. That's just called identity-based access control, which
yeah,
we know is not going to work.
you can sure I mean, that's they are labeled that operation resources, but keep in mind that you need to attenuate. In your policy decision point, you are not going to be able to attenuate. So you should have a semantic linking from what there is in the token and what the policy are actually authorizing. Because if your context enables something which is expanding the original authority, you are violating the security model. And I don't think there is a way to do this without anchoring to the root. So you are gonna still
Well,
having
let
your
me let me give a counterexample.
yeah.
So we could have a policy that says read all access on all resource should never be allowed, and we could prove that that's true, or that, and so we don't, as long as we can say what our desired state is, and we can prove that there's no condition under which that desired state is possible, then we could actually do what we call declarative security. And it's easier for us to manage risk on that. But granted, you have to be able to see the bad thing that you want to present. Like, we shouldn't be able to share all, no, we know it should not be possible to share all resources. So I
But
think you can reason over it. That is getting a little over into Cedar land about how you manage your policies. Although I think you could have declarative security without Cedar. I think Cedar is just the first example of a language or a syntax that lets you prove that that's true. But there could be others.
yeah, but the problem is if the policy are expanding the authority, you have to find a semantic link between the two. I'm not saying that you are not going to use the policy decision point. Once the continuity is full understood, you are going to understand that there are different type of policy. I'm going to give you an example. Let's suppose I have an authority which is saying allow to save to the database, okay?
Yeah.
Then I'm going to have another component which is going to save to the PostgreSQL database, okay? So the PostgreSQL database is a different capability which is save to PostgreSQL. But the initial authority said save to database. But what is the semantic linking between both of them? What I'm saying is that you start thinking continuity, the policy that will become very central and important because you are going to have multiple type of policies, not just application policy like you do today, but you are going to have also, for instance, translation policy, because when you are going to cross two domains, you need also to translate meaning between the two domains, because the policy is tied to your domain. But when the authority propagate multiple domain, how are you going to translate the meaning? That's the next challenge. And if you are propagating an authority which has some label, and between the two domains you have semantics, you will be able also to have a policy to translate the scope in the two different domains. So I think, I mean, to explain the continuity is not very easy. It cannot be done in half an hour or whatever. But I understood your point, and you are right. But when you will fully understand what I'm saying, I'm not saying that we are not going in the direction that you are pointing at. It's the opposite. The policy that will become really important, but they need to make sure that they satisfy this
Yeah.
continuity.
Right. I wasn't disputing the continuity part. I was just hassling you about. I didn't like your initial example. And I think it sidetracks your whole conversation. I think you should maybe just cut it out. I wanted, so my last question, I guess, I want you conclude the paper and you describe proof of continuity as the minimal temporal model for authority propagation. Like not just like it's the bare minimum threshold of what we need. So what do we have to do to make that real?
So to make that real, I mean, it's not so difficult. So, I mean, up to now, I've been also understanding the concept. So now we will also create a spec. I had the first version of the spec which is also mixing the architecture. And then I understood it became too complicated. So it was in my mind, it was difficult to explain. Now we are creating a second version of this spec where we are going to isolate the architecture and just define the verifier and the prover. So it's going to be easy to implement. In order to make it real, what we need is essentially to be able to associate to workloads, executor, some characteristic, some attribute that I think also the direction where WISMI, SPIFFy, they are already going. Okay, because each workload can have an identifier. To this identifier, you can attach metadata characteristic. Okay, I can know that this workload is based in USA. Then, in order to make this real, we need to be able to build the proof of relationship. This can be done in an easy way with a simple JSON, some cryptographic work. We can use verified credential, doesn't matter, it's agnostic. Then we are going to be able to create the proof of continuity using the proof of relationship. At the end, we are going to create a unique bundle, okay? This unique bundle is going to be the proof of continuity artifact that we are going to validate. Okay, we are creating a specification for this. Then, of course, there is another question. Say, okay, but if all the systems they are working with off, what are we saying? Are we going to change all the existing system? I don't think so, because we can create also an off token exchange profile that essentially is going to take a JWT token and exchange with a PIC. But the PIC itself can be also encoded in a JWT token. I mean, that's just data. So if we want to get integration, for sure we need to have a profile which is extending off token exchange in order to enable PIC. Then once you have PIC, you are going to be able to convert back to a JWT token and move to the next boundary, which is not using PIC. So I don't see it as a big problem.
Okay. Actually, pigeons should be flying soon. There we go. So I guess we're coming to the end. I guess we're roughly on time. Do you any last thoughts before we break?
Yes. So I mean, lately I'm spending lots of time on PIC. I created also a website which is pic-protocol.org. So if you are interested in the concept, have a look. If you like, you can contact me. But I think it's worth it. It's taking a little bit of time to understand the concept, but so far is proving that it's satisfying all the use case. So I'm building lots of use case, trying to assess them with other people, and the logic is working fine. So that's it from my side.
Awesome. I just want to use this time to quickly announce next episode, Patrick Parker, The Laws of A-Identity. And by the way, Patrick has the all-time most hits on his previous episode where he's in his backyard in his Hawaiian shirt. So I attributed it all to the Hawaiian shirt. So looking forward to that on Tuesday. And then just a quick reminder, please follow the live stream on LinkedIn or YouTube. We're trying to get to 3,000 right now. And with that, I will say thank you so much, Nicola, for definitely giving me more depth of understanding into this paper and where you're coming from and giving me a chance to hassle you a little bit. But I think, I think this is the direction that we need to go. We need we need math to actually prove some of these security properties. And then we need cryptography to provide the evidence or the proofs of that. And as you say, continuity and relationship is the minimum that we need. There's probably more. So anyway, thank you, Nicola, for
You're
spending
welcome.
the time. And thank you, audience.